engineer by training who chose to fish because of his interest in the sea. His job made easier thanks to information gathered via satellite, which tells him where to fish.
The potential fishing zone advisory is useful to quite an extent, especially nowadays we cannot waste time searching for fish. So if we have a potential fishing zone advisory, we know the zone where the fish is good. We have more chances of catching the fish, so we waste less time and less diesel.
A simple fishing boat from the outside, inside it's a platform for the latest technology.
I use almost all the latest equipment in my boat. I've got a DGPS on my boat, that's a differential GPS. Then I've got a Eco Sounder fish finder. I've also got a sonar that detects fish at a range of even 400 meters away from my boat.
But to put him that close to the fish, he needs to know which part of the sea to be fishing in. That's where the potential fishing zone advisory comes in. High-tech data provided by ocean scientists, marine biologists, and remote sensing experts.
What happens here is we process operationally data from NOAA satellite. We get sea surface temperature. Then we process data from IRS-P4 OceanSat, which is the Indian satellite.
Hello, hello.
नितीन ते माईक चालूच ठेव, बंद करू नकोस. अलीकडं LED वॉलच्या अलीकडे, इकडं पुढे ये. काय काय पुढे ये. गुड्डू माईक चेक घे, पुढे ये.
हॅलो हॅलो.
हां, तर पलीकडच्या बाजूच्या दोन्ही माईक चेक घे. ते दोन पुढे चेक घे. Hello, hello, check. Check 1 2. Hello, check. Check 1 2. Hello, check. Okay, बोल गुड्डू.
Hello, 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 check. Hello, check. Hello.
गुड्डू, एकदा शेवटचा पोडियम परत चेक घे. हा पोडियम परत चेक घे.
Hello, check 1.
Okay, okay.
And how it can be killed. Tell us, how does the vaccine work?
We have cloned the gene for the Duffy binding protein, and specifically the part that binds the receptor. We put it into E. coli and then grow the E. coli in this fermenter. And the E. coli produces the protein, and as I'll show you in the lab next door, we then purify the protein from E. coli, and that is the vaccine. If you immunize people with that protein, people will make antibodies, and those antibodies will block the binding of the parasite to the red cell and not allow it to invade red blood cells, thereby killing the parasite.
In achieving their breakthrough, the team have further proved the effectiveness of public-private partnerships and how challenges as big as defeating malaria require a multi-agency approach. One of the production lines at Bharat Biotech, an innovative leader in Indian pharmaceuticals, having already made a name for itself with its novel technique for producing hepatitis B vaccine, which is far less capital intensive and has resulted in far less chemical byproducts.
We thought, we should be innovative, come out a much more safer vaccine, and at the same time bring the cost down. And that was our goal. And we developed a HiMax, a new technology, which we got a global patent.
Thanks to Indian pharmaceutical firms, the costs of many drugs now available for people in developing countries have come down dramatically. Indian patent laws allowed for companies to find ways of producing generic drugs through more cost-effective and innovative means than their counterparts in developed countries.
Reduction almost more than 10 times. That brings almost, vaccine which is sold at $20 a vaccine, we're able to bring it 20 cents. I think India, to be a developed nation, innovation is the most important.
With lower production costs and an obvious abundance in talent, India is at the threshold of an exciting era in pharmaceuticals, medicine and biotechnology. One that will see it emerge in some respects as a world leader, and with the people and communities benefiting being those most in need. The timeless face of rural India, unchanging from generation to generation, but in the space of one lifetime, about to undergo a profound transformation unimaginable to our forefathers. We have come to the village of Januru in Andhra Pradesh. Outwardly very ordinary, but the appearance of the antenna means life will never be the same again. Out in a field, online and able to check my emails. The pace of connectivity in rural India has been, as we all know, phenomenal. The pace of rural development itself, less so. Using the one to help drive the other, now that would be the thing. Technology enabled, this is Project Ashwini. At a rural centre, students gather for their daily lesson from a teacher situated in a classroom many kilometres away.
Good morning, children. How are you?
A total of 32 Ashwini centres, able to reach up to 500,000 people in the rural communities they serve.
Madam, please say about the advert.
Sessions that are interactive, inviting response and participation from those involved. Their remoteness no longer a barrier in this age of internet connectivity. The Bairaju Foundation employs teachers to run classes in continuing education programs using their Wi-Fi network.
Alas, wow, hooray. Well, where we will use this hooray?
And in addition to the more traditional classroom sessions, use of other mediums such as puppets to help tell stories and impart public information. Additionally, these centres can be hooked up with studios in Hyderabad, several hundred kilometres away, to draw on the services of experts in disciplines from agriculture to health. All of these influences, ensuring the society these children inherit and pass on, will be very different from the one they were born into.
Right down the camera. You think it's a still camera, don't you? Tell me, what's your name?
My name is Satyaramya.
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 Okay. And how old are you?
I am 10 years old.
Tell me about school. Do you like school?
No.
You don't like school? Who else speaks English here? What's your name?
My name is Rajput.
Give me 5. No. Dude! Bye-bye.
See you.
Bye.
See you.
See you again. Bye-bye.
The revolution provided by the digital age potentially benefiting all down to the poorest of farmers.
I'm in a field with a bunch of farmers looking for grubs. Not quite sure what type of grubs we're meant to be looking for, but then that's the point. Once we find them, then we'll identify them.
Another application of the technology.
But we found one.
Aimed at helping poor farmers, the scheme is called Isagu. Coordinators regularly visit farmers and listen to problems. They also take pictures of pests and diseases affecting their crops. These are then sent across the internet to experts. In turn, the experts give analysis on what the problem is and how to tackle it.
Thanks for talking to us. We'll let you get back to work. Thank you.
Thanks.
Looking at scientific work that helps farmers inevitably leads to ICRISAT. The International Crops Research Institute is a non-profit body. They operate in 50 developing countries, helping the poorest of farmers.
All the innovations we've seen so far having a big effect on people's lives. But in a country where 2/3 of the population live off the land, any improvements in agriculture are bound to have a massive impact.
One recent big success, fighting the pigeon pea pod borer.
So these larvae, these will affect any and all plants, is that right? Or a lot of the legumes?
It's polyphagous. They not only legumes, it can go for cabbage, cauliflower, cotton, chilies, all cultivated crops. It's the #1 enemy of agricultural crops in Asia. And in fact, we are spending about 500 million worth insecticide to control only this pest. And the loss caused by this pest is about $2 billion.
The answer, a biopesticide, NPV, developed with the help of farmers who are encouraged to shake down their bushes to collect the larvae themselves. These are then used as the raw material for the biopesticide. This is then sprayed back onto the crops to protect them.
You get a lot from one bush, don't you?
A more effective solution to traditional pesticides, which become ineffective over time.
It's very difficult to put this pest under manageable levels only through insecticides, so we all have to look for some type of integrated approach.
So the way you found is to use the insects themselves to develop an antidote to themselves, is that right?
Exactly. The farmers shake this pigeon pea plant during the peak infestation time, collect these larvae to produce the virus.
In the transgenic lab at ICRISAT, scientist Dr. Kiran Sharma grappling with another problem affecting the poorest of farmers, malnutrition.
One, hunger is where people don't get enough calories, enough food to eat. The second type is more dangerous, where people think they are getting enough food, but it's not a balanced food. So that leads to what we call hidden hunger, where the major problem is deficiencies of essential minerals and vitamins.
The breakthrough in this lab, the world's first genetically modified groundnut, needed to avoid the health problems associated with poor nutrition.
What we're trying to tackle through this project, where we would like to have biofortified peanuts or groundnut, which can add value to the people's lives.
The greatest satisfaction coming from scientific achievement that helps people through practical application. If you want an alternative take on science, then spend some time in a community that has an alternative take on life. To the people here, the sun plays an important role, serving not only the spirit, but also the stomach.
There's recharging your batteries, and then there's recharging your batteries. The International Township of Oroville is a well-known centre of spiritualism and alternative ways of living.
In the Matrimandia, the golden sphere at the center of this idealistic community, the rays of the sun are harnessed and directed inside. They help illuminate the interior to create a space where the inhabitants can concentrate on finding their consciousness.
Don't bother me now. I'm busy.
In a place naturally concerned with using sources of energy friendly to the Earth, it would be strange if the sun wasn't widely used. Solar power is collected by individual homes throughout the township, and on the roof of the communal kitchen, a 15-meter solar bowl.
This is a part of a sphere. It's the bottom third of a full sphere. It has a line focus where the receiver is placed. So something has to move to follow the sun. So the whole receiver arm there moves. That top point points at the sun. It's actuated by a computer and small motors, and it moves like a pendulum through the bowl once during the day.
A simple design and simple construction. 11,000 small square mirrors individually placed so they reflect the sun onto the swinging arm receiver.
The structure of the bowl is made from prefabricated ferrocement elements. So there's no metal structure below. It's made up of 96 pieces which we made on the ground and assembled them to get this spherical shape. So that's one aspect. And then the simple application of the mirrors done by ordinary team from the village which we had working with us. From the boiler room downstairs we have a small simple pump. It pumps water up this mast, down the arm, and then it comes spiraling up, and about halfway up it starts to turn into steam, and at the top we have a good steam production, then out the insulated pipe back to the kitchen.
Let there be steam. Pumped back into the kitchen below, the steam needed for the hundreds of meals cooked here each day. Operated in tandem with the kitchen's diesel boilers, staff have found they can save 20% of their fuel costs, all thanks to the sun and a little alternative thinking. Evening on the coast of Goa. Deceptively calm on the quayside. Go beyond the harbour wall and there's no protection from the stomach-churning monsoon swell. From our small fishing boat, trying to scale the towering sides of the Sagar Kanya, an adventure all its own. Buffeted and banged against her steel for half an hour, it's decided. Our gear goes up in the cargo net and we go up the rope ladder.
So late at night here just off the coast of Goa, we've finally made it on board through the heavy swell. Us, our equipment in the cargo net, and about to find a cabin, hopefully. This is the dirty end of ocean research, as you can see from my trousers here. Time to go and find a cabin and move some boxes. Let's go.
Signing on for our cruise, we're following in the footsteps of a generation of oceanographic scientists. The Sagar Kanya is something of a floating institution. Commissioned in 1983, the vessel has been the flagship of India's research and exploration endeavours on the high seas.
Sagar Kanya, it means the daughter of the oceans, the daughter of the sea. And it's quite a prestigious vessel with India, built in 1983, it's around 24 years old. It's a multidisciplinary institutional vessel, and practically all the science institutions in India, they make use of this very vessel, whether it's the universities, it's the government organizations, it is the research institutions. It has got biological labs, it has got marine geological labs, geophysical labs, and all sorts of geophysical equipments it has gravimeters, It has sub-bottom profilers, everything that you can think of.
Our journey is taking us westwards into the Arabian Sea. But throughout the year, the vessel is kept constantly busy with missions not only on this coast, but also in the Indian Ocean and the Bay of Bengal. On these trips, it will constantly sample the seas, taking measurements for many different properties, from salinity and temperature to the existence of plankton and dissolved nutrients. Samples are then analyzed in one of the ship's 14 different laboratories. It all contributes to India's understanding of the seas and weather patterns that surround its vast coastline, and which affects such universal phenomena as the monsoon.
The sensors and samplers on this side of the vessel are largely concerned with testing the properties of the seas we're passing through. The ones over this side go much deeper, down to the seabed itself. For despite all our knowledge of the world and the way it works, the ocean floor itself remains a relative mystery, but one of boundless potential.